If you have ever bought an LED grow light, a hydroponic kit, a bag of indoor potting mix, or a bottle of liquid plant nutrients to grow food inside your home, you have been sold the most expensive solution to a problem that does not exist. The indoor gardening industry told you that growing food without sunlight requires technology, panels, timers, spectrum controllers, nutrient reservoirs, grow tents with reflective lining. The entry-level setup at any hydroponic store starts at $150. A mid-range system runs $400 to $600. And that is before the electricity bill, because those lights run 14 to 18 hours a day, every day, for weeks. All of this to grow a handful of greens you could buy at the grocery store for $3.99. But here is what that industry never told you. For the first and most critical stage of a plant's life, the stage where it produces the most nutritional density per ounce, a seed does not need a single photon of light, not one. In fact, light during this stage actively slows growth and reduces yield. That is not an opinion, that is photobiology, and it has been documented in peer-reviewed research for over a century. The global indoor farming and controlled environment agriculture market was valued at $14.2 billion in 2023. The home hydroponics segment alone generates over $1.5 billion in annual retail sales. Every dollar of that revenue is built on one assumption, that you need light to grow food indoors. What if the most productive stage of plant growth happens in complete darkness? You do not need a grow light, you do not need soil, you do not need a hydroponic system. You need a plastic bin with a lid, some seeds, water, and a closet. Total cost, under $5. Setup time, 5 minutes. Time to harvest, 5 to 8 days. And the nutritional density of what you harvest from that $5 bin will exceed anything on the produce shelf at your grocery store. Welcome to the invincible method. Today I am going to show you the biological loophole that the indoor gardening industry hopes you never learn. And it is the simplest, cheapest, and laziest method of growing food that exists. Seed 2. The origin, the biology of darkness. Every seed on Earth carries a packed lunch. That is not a metaphor. It is a biochemical fact. Inside the seed coat of every viable seed, wheat, sunflower, pea, radish, broccoli, is an endosperm loaded with stored starches, proteins, lipids, and minerals. This energy reserve was designed by 400 million years of evolution for one purpose: to fuel the plant's first days of life before it can photosynthesize. In nature, most seeds germinate underground. There is no light below the surface. The seed does not wait for the sun. It cracks open and powers its initial growth entirely from its own reserves, pushing a stem upward through soil in search of the surface. In darkness, the plant prioritizes one thing: vertical growth. It elongates its stem as fast as biochemically possible, burning through its energy reserves at maximum speed to find light before those reserves run out. The stems grow long, tender, and pale. The leaves stay small and folded. Every calorie is converted into rapid upward expansion. This phenomenon is called etiolation. And for 150 years, plant science has treated it as a defect, a symptom of inadequate lighting. Textbooks call etiolated plants weak, leggy, and unhealthy. But here is what those textbooks leave out. An etiolated seedling, harvested between day 5 and day 10, is one of the most nutrient-dense foods a human being can eat. Because all of that stored seed energy has been mobilized. It is not locked inside a dry kernel anymore. It has been converted into bioavailable, living tissue your body can absorb immediately. Dr. Jean Lester, a research plant physiologist formerly with the USDA Agricultural Research Service, published data showing that young seedlings contain between 4 and 40 times the concentration of vitamins C, E, and K compared to their mature counterparts. A 2012 study in the Journal of Agricultural and Food Chemistry by researchers at the University of Maryland confirmed these findings across 25 microgreen varieties, noting that the highest nutrient concentrations occurred in the earliest harvest stages, before significant photosynthesis had begun. Before significant photosynthesis, meaning before light mattered, the seed does not need your grow light to produce nutrition. The seed already contains the nutrition. Germination does not create nutrients, it unlocks them, and it does that fastest and most completely in total darkness. Now here is what the industry does not tell you. When a germinating seedling detects light, specifically blue and red wavelengths, exactly what LED grow panels emit, it triggers a photoreceptor response that slows vertical elongation. The plant thinks it has reached the surface. It begins unfurling leaves and redirecting energy toward building photosynthetic machinery. Chloroplasts, chlorophyll, thylakoid membranes, instead of growing taller. Light tells the seed to stop growing fast and start growing permanent. If your goal is a mature plant that will produce fruit for months, light is essential. But if your goal is a dense, nutritious harvest in under 10 days, light is your enemy. It slows the very growth phase you are trying to maximize. Every grow light sold for sprouting and microgreen production is actively sabotaging the biology it claims to support. So why does the industry sell them? Let us quantify this, because the numbers are what the industry cannot argue against. Take an identical batch of seeds, split them into 2 groups. Place one under a standard full-spectrum LED grow panel at the recommended 14 hours of light per day. Place the other in total darkness under a closed lid. Under light, the seedling activates photomorphogenesis within 48 hours. Stem elongation slows by 30 to 50% as energy diverts toward chlorophyll production. By day 7, you have a short, compact green seedling. In darkness, the seedling never slows down. It continues burning stored energy into vertical growth at maximum rate. By day 7, you have a stem 3 to 5 inches tall, 2 to 3 times the height of the lit counterpart. Pale, tender, and packed with mobilized nutrients never diverted into photosynthetic machinery. The dark-grown seedling produces more edible biomass, faster, with zero energy input. A 2019 study at the University of Copenhagen measured shoot length, fresh weight, and dry weight in pea, sunflower, and radish microgreens. Grown under 4 light regimes: full spectrum, red only, blue only, and total darkness. The dark-grown seedlings produced the greatest fresh weight yield per tray in every species tested. That is not a typo. Darkness outperformed every light condition. But here is what makes the prescription remarkable. Nutritional analysis of the dark-grown seedlings showed no decrease in vitamins A, precursors, C, and K, compared to light-grown controls. In some varieties, particularly pea shoots and sunflower, dark-grown seedlings showed higher concentrations of B vitamins and essential amino acids. The light-grown seedlings had traded nutritional density for greenness. The dark-grown seedlings kept everything. Now the cost comparison, because it is devastating. A standard growing tray of sunflower microgreens requires approximately 2 ounces of seed, roughly 40 cents of bulk seed. Grown in darkness, no electricity, no soil, no nutrients. That tray produces 8 to 12 ounces of edible greens in 7 to 9 days. At the grocery store, a 5-ounce clamshell of organic microgreens retails for $3.99 to $5.99. You just produced double the volume for a tenth of the price. Scale it. 4 to 6 trays on a stagger, starting 1 every 2 days, inside a single closet shelf. That produces 32 to 72 ounces of fresh greens per week, continuously, for pennies, in the dark. The industry's recommended beginner setup: LED panel at $89, rack at $45, timer at $15, trays at $30, growing medium at $18, liquid nutrients at $22, pH kit at $12. Over $230 before you grow a single leaf, plus $8 to $15 per month in electricity. Forever. The darkness method costs $5. The electricity bill is $0, because the closet door is closed. A product that costs nothing cannot sustain an industry. So the industry made sure you believed you needed light. Act 4. The suppression. Why the industry needs you in the light. The indoor gardening and controlled environment agriculture industry is projected to reach $24 billion by 2030. The home segment, grow lights, hydroponic kits, smart garden appliances, nutrient solutions, is growing at over 10% annually. This growth is not driven by people who need to grow food indoors. It is driven by people who have been convinced that growing food indoors is complicated. Complexity is the revenue engine. Every additional component, the light, the timer, the nutrient mix, the pH adjuster, the growing medium, the ventilation fan, is a product. Every product is a sale. The more complex the system, the more money spent. A plastic bin and a bag of seeds generates one sale, under $5, then produces food indefinitely. That is commercially useless. It cannot be expanded into a product line. It cannot generate subscriptions or replacement parts. So the industry did what every industry does with a simple, free alternative. It made it invisible. Search how to grow microgreens on any major platform. The top results overwhelmingly feature grow lights, specialized trays, cocoa coir, and nutrient solutions. The darkness method does not appear, not because it does not work, because nobody selling a product benefits from teaching it. Extension bulletins from land-grant universities recommend adequate lighting as essential for indoor seed starting. Gardening magazines describe etiolation as a problem to avoid. The word itself has become negative, a synonym for failure, for neglect, for doing it wrong. But etiolation is not failure. It is the seed doing exactly what 400 million years of evolution designed it to do: sprint upward with everything it has, converting stored energy into living tissue at maximum speed. The industry reframed a biological feature as a flaw because the feature eliminated the need for their products. What does not generate recurring revenue is not taught. Reactivating dead soil does not require a purchase, a machine, or a chemistry degree. It requires one action, performed once, using material that is free in every neighborhood on Earth. Here is the protocol. Step 1. Stop tilling, immediately, permanently. Do not turn the soil, do not rototill, do not double dig. Every act of tillage severs fungal networks and resets the biological clock to 0. The soil must be left physically undisturbed from this point forward. If the surface is compacted, it will decompact itself. Biology does this work for free, but only if you stop destroying it. Step 2. Stop applying synthetic fertilizer, immediately. Step 2. Stop applying synthetic fertilizer, immediately. The chemical salt suppresses the microbial community you are about to rebuild. This is the hardest step psychologically, because your plants may look slightly worse for 4 to 6 weeks during the transition. That is withdrawal. The biology is rebuilding. The plants are learning to feed through fungal networks instead of chemical drips. Do not panic. Do not relapse. Step 3. Cover every square inch of exposed soil with raw organic matter. This is the core action. This is the engine. Pile it directly on the surface. Do not dig it in. Do not mix it. Do not incorporate it. Just lay it down. What to use? Fallen leaves are the highest value material. They are preloaded with trace minerals pulled from deep in the ground by the tree's root system. Grass clippings provide fast-release nitrogen. Straw provides structural carbon. Grass clippings provide fast-release nitrogen. Straw provides structural carbon. Straw provides structural carbon. Vegetable kitchen scraps, peels, stems, cores, coffee grounds provide a diverse nutrient profile. Vegetable kitchen scraps, peels, stems, cores, coffee grounds provide a diverse nutrient profile. Vegetable kitchen scraps, peels, stems, cores, coffee grounds provide a diverse nutrient profile. Wood chips from arborists, often free for the asking, provide long-term carbon and are the single best food source for mycorrhizal fungi. Wood chips from arborists, often free for the asking, provide long-term carbon and are the single best food source for mycorrhizal fungi. The ratio does not need to be precise. Nature does not measure, but a general guideline: 3 parts carbon-heavy material to 1 part nitrogen-heavy material. Layer them like a rough lasagna. Brown, green, then stop. The ideal depth is 4 to 6 inches. Deeper is fine. Shallower works but decomposes faster and needs replenishing sooner. Step 4. Walk away. The decomposition army is already present in the material itself. Bacteria on the leaf surfaces, fungal spores in the soil beneath, earthworms that will migrate upward. Within 2 weeks, fungal hyphae will begin threading through the bottom of the organic layer, pulling nutrients downward into the soil. Within 2 weeks, fungal hyphae will begin threading through the bottom of the organic layer, pulling nutrients downward into the soil. Within 4 weeks, earthworm channels will start opening in the compacted surface, creating drainage and aeration without any mechanical intervention. Within 8 to 12 weeks, the bottom 2 inches of your mulch layer will have transformed into dark, crumbly humus, indistinguishable from the forest floor of a 200-year-old woodland. Dr. Elaine Ingham, founder of the Soil Food Web School, has documented that surface-applied organic mulch can restore measurable microbial activity to chemically degraded soil within a single growing season. Her lab analyses showed that fungal to bacterial ratios shifted from the bacteria-dominated profile of degraded soil to the fungal-dominated profile of productive soil within 90 days. 90 days, 1 season, $0. Step 5. Replenish the surface layer every time it thins. As the bottom decomposes, add more on top. Leaves in autumn, grass clippings in summer, kitchen scraps year-round. The system is self-accelerating. Grass clippings in summer, grass clippings in summer. The more biology you build, the faster new material breaks down. By the 2nd year, you will have more earthworms and fungal activity than any synthetic program could produce. Do the work once. The biology handles the rest forever. Act 6. Closing and call to action. You have a choice. You can drive to the garden center again this spring. You can load bags of manufactured fertility into your trunk, carry them to your yard, tear them open, pour their contents onto soil that gets weaker every year, and pretend this is gardening. You can keep feeding the plant and starving the soil. Tear them open, pour their contents onto soil that gets weaker every year, and pretend this is gardening. You can keep paying for a system that requires you to pay again next season, and the season after that, and every season until you stop. Or you can walk outside, gather the organic matter your neighbors are throwing away, pile it on your dirt, and let 400 million years of biology do what it has always done. Every forest on Earth runs on this method. Every prairie, every wetland, every ecosystem that has ever sustained itself without human intervention operates on one principle. Dead things fall on the surface, living things eat them from below, and the soil gets richer every single year. The synthetic fertilizer industry intercepted this cycle. It replaced a free, self-sustaining system with a purchased, self-depleting one. and it convinced 3 generations of gardeners that soil cannot feed itself, that dirt is inert, dead, and useless without a product from a bag. That is the lie. Your soil is not dead, it is dormant, and the wake-up call is not a chemical, it is a leaf. The knowledge survives. What you do with it is yours. If this changed how you think about soil, subscribe to the Invincible Method and hit the bell. Share this with the gardener in your life who is still buying bags every spring. Every like pushes this past the algorithm that profits from keeping you dependent. The next method drops soon, and it turns everything you just learned into a single, permanent system.